All right, I'm Robert Watson. I teach computer science and physics here at Cisco. And I'm here today to talk a little bit about engineering and computer science and Cisco. I did not graduate. I went to school here at Cisco, started here at Cisco, and transferred to engineering school and got a degree in computer and electrical engineering. And being a computer engineering degree, there was quite a bit of programming involved, a lot of software as a part of that. And I used that in my first job after I graduated. I was an electrical design engineer for the Air Force, but our squadron, I was civil service, when they got ready to start using computers to do our design work, I ended up being the engineer sort of overseeing that, acquiring the equipment and the software that we used and getting all of that installed and organized, get the contracts written. After I had been there long enough, I completed my engineering license. And about that time, I realized that I had gotten about everything out of that job I could, and I quit and went to work for myself, writing software, contract software for companies. And I did that for quite a long time, writing software, in doing a variety of different things. I wrote software for credit card processing, primarily in convenience stores that would do the pay at the pump sort of. That was still relatively new at the time. And I was doing a lot of work for a company that was kind of a pioneer in that. And I wrote a variety of different systems beyond that, systems that they used to test their own software. So it was internal software that would test the software they were producing for our customers. And I wrote, and so I had software there that was running all over the country, all over the U.S., and quite a few, they had, their software was running in quite a few different countries, including China. I did one fairly large project that was running in Hong Kong, which then was also used in Macau and China. And then I had the opportunity to go to graduate school, so I did that. And when I graduated, I started teaching. So I started yet another career. And in teaching, while I was teaching, I still had my company, my development company, and some more opportunities came up there, and I began doing product development. So now I was having a chance to do electrical design for embedded systems for a company, developing their products and the software that ran with them. And so the software kind of expanded, writing software that went in the product, embedded software systems, but also the software supporting it on Android and other platforms. So I began developing more products that way, and I'm still doing that. Actually, I spent this summer redesigning the same products because the chip shortage hit them too. Finally caught up with us. We've been running from the chip shortage. I've been doing their production for them. They didn't want to get into electronics manufacturing because that's really not what they do. They were just selling tools. And so I would manufacture the electronics and just resell them to them. And the chip shortage has been on our heels for years now. And we always stayed ahead of it until this summer, and they were just gone. And it required a redesign. This is the second time that's happened. Previously, a component we were using just got discontinued. You know, we have to go and redesign to use the new components. This time, several parts don't exist, won't be seeing them for a long time, if ever. And spent all summer doing that again for them, and then adjusting the software to work with it. and completed that just about the time this semester started. Then and then now I'm still working, developing some more products. This is for a different company that in this case, I'm actually partnering in. So I actually have a share in the outcome. And again, it's embedded electronic design, development, getting the product tested, figuring out how to make it, how to get it to work. And that's just straight engineering work. Just how do you we have a goal, we have something we want to do. How do you do it? What are the physics involved, right? And what do I have to measure? Can I measure it? There are many different approaches. Which ones will work? Because not everything works, and we're in the process of experimenting with that and getting it going, and then doing the prototyping, software development. And so so from an engineering standpoint, it's been a mix of software on top of something else, right? Something, some other domain other than just software. It's always been involved with finance. In graduate school, I spent some time working in robotics. That was a part of the graduate work I was doing, and I was thinking about using robotics, autonomous robotics, as my dissertation subject. But I was invited to work with programming languages. There was a very strong language group at that school at the time I was there, and that was of a particular interest to me, programming languages, because I thought I still think that is an area where there needs to be some serious improvement. Our languages aren't supporting us as well as they should, so I had a chance to work in that. And so it's been, and so software has kind of always been an essential component of everything I've been doing. And that matters to you, because regardless of what your major is, even if it's not engineering, there is some research done a number of years ago. And that research, the outcome of the research indicated that one of the more difficult jobs to fill, in fact, the most difficult job to fill, was a job that required programming. It took the longest time to find a qualified candidate and hire them for the job. And the takeaway from that is not that programming is a very much in demand. There's always a shortage, and has been for a long time. But that's not what this research was showing. This research was indicating that it was difficult to find someone who knows how to program, but their job is doing something else, right? And what it is, there's a domain expert, and software is needed in that domain. And this is for all domains. Computers are used in everything we do. No matter what career field a person selects, software is needed. And somebody has to write that software. You can say it's biology. You can hire a programmer, teach them biology, now they can write software in that field. They understand the field, they can write the software. Or you can hire a biologist and teach them to program. And it turns out it's better to have your domain expertise in your subject domain the software is applied to. And that is what made, and so that's kind of what this research showed, was that these were companies who needed someone who was an expert in some field who could also write software for them, and those were hard to find. And so the thing that I've tried to encourage students since then to do is whatever your field is, whatever you want to do, if you can add some programming to that, especially if you can add a programming certificate or a software engineering certificate, something of that sort to your degree, or if it's just classes, learn how to program, learn the some of the basic techniques that you wouldn't pick up on your own, add those to your skill set, that can open doors for you. That can give you opportunities later to career opportunities, jobs that you now are qualified for that you wouldn't have otherwise, or just an advantage when applying for a job that you wouldn't otherwise have to help you either land a job you want or maybe get a little bit better salary because you have a skill set they can't find easily from anyone else. And looking back, that's kind of how my career has been. It's been when I first started on my own, I encountered some people I had indirectly done business with before, and their company was pure software, but it was an engineering company. They did engineering work, and they wrote software for engineering, and there were engineers who started the company, wrote the initial software, and were still running the management, but they were hiring, in addition, because their program had grown, pure software people to work there, and they were moving into graphics. They were converting their application to do graphical applications because it was a very graphically oriented thing. And I ran into them in town and got to talking, and they found out what I was doing, and they said, well, you know, send us your resume because we're doing that now, and people who have this skill are hard to find. People who can write graphics programs on Windows. At that time, that was a skill that was not readily available, especially in West Texas. So I did, and they weren't hiring at the time, but it was a few months later, I got a strange email, just said, thank you for, you know, your application. We're going to put it on file, and we'll keep it here in case we need someone later. Well, I didn't actually apply for a job. I just sent them my resume. They asked for it. And it turned out they handed my resume to another company that they knew who was looking for someone to write software. And it actually made a big difference. I acquired a client that way. And that was a big step for me in getting my, my own company started. So, and so that's why I've always encouraged, and two of you anyway, right, encouraged you to get into software, or you're getting into software. Either you expect it to be required in your degree, or it's a good addition. And I think, but it doesn't just apply to engineering. It applies for everyone. And I've always tried to get all of our students to take some programming somewhere if they can. Right. You have any questions?
So, let's say that you're our age again. What got you interested in this field?
Well, I have the advantage that I can remember when the PC industry was invented, basically in the mid-'70s. It was 1975. And our library subscribed to Popular Science, I believe it was a magazine that carried an article to build your own computer. Well, up until that point, computers were very interesting things, but they were mysterious because nobody had ever seen one, right? I mean, they were massive multi-billion-dollar machines that had a building, at least a very large room, if not an entire building dedicated to that. When I went to college, the college had a building dedicated to their biggest computers. So there were computers all over campus, but one building, the main computer that ran everything. And so it was, so nobody actually had one because they were expensive and they were big. And if you did have one, what would you do? Well, hobbyists would have a lot of fun. I would have. I thought it would have been great, but I didn't know how they worked. They were one of those things I could not figure out how they worked. Most things, you know, if you're interested in engineering and science, you kind of look at things and try to figure out how they work, and you can usually figure it out. Computers, I had no idea. And so this article was published, and you could build your own, and it was kind of affordable. And I thought, well, I really wanted to do that. I didn't, but I wanted to, and so I began to because to me, the computer was unlike anything else in the world. It still is. We build tools, right? Everything is a tool of some sort. We have tools for all sorts of different jobs, and these tools are all very, very specialized. They only do a few things. The computer could do anything. It was a tool that was not specialized in any way to do any job. You can apply it almost without limit, and that really got my attention. And I saw that right away because at the time I had a math teacher in high school who, because a lot of the students like to talk in class, would assign, write, "I will not talk in class" 500 times and turn it in. I thought, a computer hooked up to a pencil could do that for me, and then I wouldn't have to. And that was my thinking, was, this thing, I can be George Jetson. The computer can do my job for me, and I just stand around and watch it go, right? And I really liked that idea that the computer could do my job for me, and I wouldn't have to. And so today, my programming class, I don't sit down, usually somebody sits down and checks programs to see if they work, and that's time consuming. I don't. The programs are downloaded from the internet that the students write. They go right into a program that tests them, that I wrote, custom written. It tests all the programs and then prints out reports. And then I go over the report, verify whatever the report finds, hand them back to students, right? Computer's doing my job, and I like that a lot. It doesn't work quite as well as I first thought because there's a lot of work in writing the software that's going to do your job. And, it may not work out if you don't, if it's not programming, testing programs is enough work that it's a benefit. Right? But if it's something you don't do too often, it doesn't help. So anyway, as these and so that, after 1975, that's when the personal computer industry just exploded. And by 1980, IBM was involved in selling IBM PCs. And so I looked at, when I figured out what engineering was, because when I was ready to go to college, I really had no idea what I wanted to do. And when I discovered engineering, and I'm reading the catalog at the engineering college, university, I thought, this is the only thing I ever wanted to do was engineering, and I had to choose a field. And I spent a long time looking at a lot of different fields, and I settled on one of, I made up my mind, it would have to be a core engineering discipline. I'm not going to go to school for all these years and put all that work into it to get a degree that nobody needs engineers of that sort. And so that narrowed it down to, in my mind, electrical, mechanical, and civil. Looking back, chemical and petroleum are also good choices, but they were not on my radar. And then I discovered I can get a degree in computer engineering that has electrical engineering written on the diploma. I thought, okay, that's me. I get to do what I want. I get the best of everything from my perspective. And so I went into that. I thoroughly loved the subject and enjoyed it a lot and did well. But when I graduated, my first job, you had a diploma with electrical engineering written on it or you didn't get the job. It was mandatory. And so that kind of, in a sense, validated my choice, that it had to be something that was a core engineering discipline. And so my degree had to say electrical engineering. It did matter for that job. For everything else, not so much, right? Everything else I've done since. And so that's what got me interested. I was here at Cisco, actually, taking classes and studying computers, on my own as much as I could. I finally figured out how they worked, which was nice. I finally figured out how they actually operate internally. And so then it's like, okay, that's no longer a motivation, but that's okay. There are so many reasons to study computer engineering that I never slowed down. Never looked back, never questioned it. More questions? What is your major? Or what?
Engineering.
Engineering? So you still have to pick a discipline. Not an easy choice. I didn't find it an easy choice. I would just read the course catalog, see what all was being taught in each one of the engineering disciplines, and and try to decide what looked like the most fun. And because I was old enough to watch Apollo 11 land live, launch, land, return live, aerospace was very attractive to me, and I thought real hard about going aerospace, but eventually decided that was too narrow a field for what I wanted, and decided not to. So, no more questions?
Before you got the Air Force job, in college, did you get any opportunities to work for any other companies?
Okay, so in college, did I have opportunities? Yes. Did I take advantage of them? No. I was strictly focused on classes. And I had part of the problem was I grew up in construction, which helped me a lot with the Air Force. That was construction. And so my construction experience was invaluable. But I was focused on that, and I had so weekends or whenever I had time, I had a job that paid better than almost anything anyone else could get, because I was getting carpenter wages, which is good for a college student, and so I didn't really need a source of money. It looked to me like it was going to pull me away from the things I was working on, which was school and working, and so I didn't do it. But those opportunities were definitely there in engineering school. Most of the people I went to school with, they were interns somewhere, and so when I graduated, the other thing was finding a job. That was a big thing going on campus. Was the big companies, the big employers would all be coming to campus, because it's a big engineering school, looking for engineers, interviewing everybody, and I didn't do that either. Hard to say why. But when I graduated, I had by that time decided that I wanted to be in the Abilene area, because I was in a large city, and I decided, I don't like it here. I'm not going to move here. And so I was, at that time, defense was the single biggest employment opportunity for say, computer engineers, electrical, anybody that was working in the technology, defense technologies. That would have included mechanical, aerospace, electrical, and as well as some others. And Fort Worth was a big employer there, so I figured, well, I can go to Fort Worth. I can use this. I can get a job there. But I was going to try to find one here in Abilene, so I just didn't even go with the interviewing, and so I came here and did end up finding a suitable job there at the Air Force, which it suited my purposes. It was satisfactory for me, and I took that job with a list in my head of all the things this job had to offer me, right? Pay off my debts, I needed a new vehicle because I'm driving my college vehicle. I needed a computer because I'm a computer engineer, and I own a computer I took to college. I need an up-to-date computer. And this list of things, and the last thing on my list was getting an engineering license. This was the perfect job. If you want an engineering license, this was the job to take to get there. And I thought, well, I'm not going to be there that long, so that's on the list, but it's on the secondary list of things that it could have to offer, but I'm never going to be here long enough to achieve. Well, one day I achieved that, and I thought, okay, my list is empty now. There's really nothing. I've accomplished everything I can in this job, and I decided it was time to try something different. But today is a different day, though, with internships. It's a different employment environment for you looking for a job and for employers trying to hire someone, and they would really like to know who they're hiring before they hire them now, more than before. And so that's where the internship comes in. I mean, that's kind of a chance for an employee and an employer to kind of check each other out and decide, is this a good fit? Is this somebody we want working for us? So I think it's more important now than it was then, much, much more important. in terms of your ability to get a job after you graduate. When I was teaching at a university, we had a number of students, quite a few. They were hired at least a full semester, if not a full year, before they graduated. We were doing well with employers at graduating students that they wanted to hire. And so that was working well. And internships and other things that got our students in front of the employer so they could see them and see how well they did made a difference. It gave them that chance to see the student and decide if they liked them or not, and then get them to take the job, to accept the job, and an employment job, even though they still may have had as much as a year of college left to go. And that's the advantage of, that's how powerful programming is among, there are certain job fields where the demand is so high, employers would like to lock in a candidate that much in advance when they can. All right, any more questions?
As a computer and electrical engineer, what do you think is the biggest challenge that you faced in the field?
In the field. Are we talking about with the design work itself?
Biggest challenge you faced, whatever you think.
The biggest challenge I have faced. Okay. Well, let's see. One is when you are given a set of requirements that stretch the limits of, that are a bit of a stretch of the technology. It's like, nobody's done this before. I'm not 100% sure we can. And then they add some more requirements on that make sure that your budget is like this big, and the budget you need is that big. It's like, okay, something's got to give, right? We're not going to get there this way. That can be a real challenge. Maybe one of the most challenging things, and this was the project I mentioned that I took on, that was it was in Hong Kong, but it was American. I had an American customer, but the project was for their customer in Hong Kong, and they had hired someone to write the software and do the hardware for the project, and they spent their budget, they spent their time schedule, and they're approaching the end, and it's not working, and they were about to have penalties imposed for not delivering, and they couldn't get it to work, and they asked me to debug it. So I says, and that's, as a contractor, you don't do that, because you could end up being a scapegoat, right? So it's ill-advised. And I heard myself on the phone saying, yeah, sure, I'll do that. It's like, wait a minute. First off, I really don't care to travel, so I don't want to go overseas, but I just agreed to it. Secondly, I took on a job that may be impossible, and I just agreed to it. And I realized right then that I can't turn down that kind of challenge. I didn't even think about it. I just heard myself agreeing to it. And when I got to work, they said, okay, we need you here for Monday. This is the weekend. And I showed up and I started fixing the bugs it was holding up all the other people on the project. So I started working on them, whatever needed to be done. I had 4 weeks. They only had 4 weeks left. So I had 4 weeks to fix it. And then we were going to go do the delivery. That'd be another 4 weeks. And so I began working on it. And while I'm working on it, I'm reading the specifications and looking at their code and reading the specs. And after a week, I had things, everybody else was busy. I gotten that part done. And then I says, look, here's your delivery specs. This is the performance specs that you've got to meet. It's not going to meet them. It can't be. This is not going to ever meet performance specs. I'm going to have to make some major rewrites. And for some reason, they said yes. I don't know why. It sounds like a disaster to me. And so I spent the next 3 weeks, and I pretty much rewrote the program in its entirety. And when the time was up, I wrote another program to test the program we wrote to check the performance, so we could measure performance, show that we were meeting it, and then pack up, and we went to Hong Kong to do the delivery. And when we got to Hong Kong, there was a lot of stuff not working, and I kept asking, it's like, what about this requirement? Oh, don't worry about it, I'll take care of it, you know. Well, when we got to Hong Kong, I pretty much doubled the size of the project, doing all of the other things that hadn't been done yet, right? But they avoided their penalties, and we ended up delivering the whole thing. And it was a lot of fun. I mean, that's about the most fun I've ever had, because it was like an impossible situation, and for whatever reason, I thought I could do it, and we got it done. It turned out, if I had known what I was getting into, I would have told them, no, this is impossible, but I didn't find out until I was already on the project, you know. And so we got it working, and it ran for years and years. And initially, it was just Hong Kong and Macau, and then after I was done and left, it was always a part of the plan, was they expanded that system out into China itself. And at the time, Hong Kong was still British, and so it was just a really interesting experience. Anything else?
Maybe one more question.
Okay.
So going back to our age, what one thing would you change that you would have done?
What would I have changed? It'd be a lot of things I would change. If you, knowing what I know now, what would I do different? I would do a lot of things differently. It's kind of a difficult question to answer, because I know stuff now that would have been so awesome to know back then, right? Everybody does. But I would have approached my college a lot differently. One of the things that makes being a college student difficult is debt, right? So you're borrowing money, and so you know you got to pay it back, and so you're trying to avoid spending more than you need to, because the more you borrow, the more difficult it is to get repaid. And looking back on it, I ended up not borrowing much money, which was great, but I shouldn't have been so worried about it, right? It's not, especially if you have a major where there's a lot of demand for your field, you can get a job, right? Engineering, in the employment market's changed a lot. At that time, in the technical fields, engineering, computer science, the media would do these projections, and they would figure out, okay, there's going to be this huge demand for this career field. Students would pile in, and then after a couple of years, there'd be a glut. But in engineering, at least, it would only take a couple of years, and the glut's gone, right? So it's not. It looked at, as a student, it looks like, oh, that's terrible. There's just all these people taking jobs. Like, they're still finding jobs, and very shortly, there's going to be a shortage again. That's how this field works. It doesn't seem to happen. Students don't seem to respond that way anymore. They're not watching the news and saying, there's a big demand for this particular engineering field, I'll go there. They're making their decisions some other method, you know, some other criteria. And so I really shouldn't have been that worried about it. And that would have made college a lot easier. And engineering in particular, the information's coming at you extremely fast. At that time, there was a lot more hours in an engineering degree than there are now. The state has cut it back. And so that's a lot of stuff. And now you've got 120 hours, and they've got to pack everything they want you to know into that 120 hours. And it's going to be a lot. And so you really need to you really don't want too many distractions, right? Because the more you can pick up while you're there, well, that'll improve your GPA. That's important. But also, that information's it is good information. Hopefully you will use that after you graduate. Some students don't. They just kind of let it go. But if you're able to retain and use that information that you were taught in college, it can make a very big impact on how well you do your job afterward, which will have a big impact on how well you succeed in your field. And I was sort of middle of the road, or thereabouts. I would like to have done better than I did, but stress and all of that kind of makes things more difficult. So yeah, it would have been better to have a better understanding of what's going to happen after college. All right, that's all our questions? Okay.
What classes did you take at Cisco?
Okay, well funny you should ask. I did take 6 hours of calculus. That's all that was offered. So when I got in engineering school, required, let's see, 16, and the first so the first two courses were 8 hours total. So I ended up with 17 because they have a course in engineering school made exactly for people like me to get those extra 2 hours, right? Catch up. It was not a big deal. I took most of my basic courses. I took English, history, government. I took chemistry because I assumed, well, it's engineering. Of course I need chemistry. Turns out, no, I didn't. I took it for no reason. And I did not take chemistry. I did not take physics because I couldn't get the prerequisites in because I was put into algebra when I got here and I did not need algebra. But when I got to engineering school, it turns out that is one of the courses they use to separate out the students who aren't going to make it as engineers. And they told us at the first week, it says only about 30% are going to pass this course. And it's a course with several thousand students. My section was probably 500 students. And your professor is this little teeny guy, you know, like a half a mile down this auditorium. And I once tried to talk to the TA for my section, and after standing through a long line, I said, okay, this is not going to help me either. And so I survived. I got through that class and did okay. And I thought, you know, before I come back, I'm going to go back to Cisco and take the second course, the second half of physics. So I did. I came here. I took, and of course, now I'm in a room like this, you know, a small number of students. I can talk to the professor. I can ask questions. I learned a lot more physics here than I was there. And of course, had a much better grade, right? And so I wasn't, it was a lot less stressful. So I took physics here, the second half. The first half, I did the hard way. And then let's see, what else? I took typing. At that time, I never had the opportunity to take typing in high school. Students seem to take it for granted these days, but they're also not, their typing skills are not what they would have been back then when people had actual typewriters. And typing was a big career component for typists, right? And I thought, well, if I'm going to be computer engineering or anything with computers, I really need to know how to type. So I took a typing course, and that was one of the better ideas I ever had. It has served me ever since because, you know, I spend all day, every day typing. And being able to touch type and to type fast and to type reasonably accurate. I've lost a lot of my accuracy, but that was a big, that was something that was kind of out of the ordinary here. And something you probably don't pick up at a large university either. But you come to Cisco, and there are a lot of courses available of that sort that can fill in things you might otherwise not realize were important to you. You have any more questions?
So what would you recommend to these students that they take while they're at the community college?
I would look for opportunities, you know, and I did that all the way through engineering school. I went to a large engineering school, and so courses would come along, special topics courses that they teach, which is something that interests the professor, but it's not in the catalog. And your degree plan has spaces for electives, and that's where those go. And I always kept my eyes open for these coming along, and a few of them came along, and I always signed up for the special topics courses. You're learning something that the professor cares a lot about. It's interesting to him. That's going to make it interesting to you, It's sort of off the beaten path, and that's the kind of opportunity. So here at Cisco, you can look at the courses offered and say, would this, to the extent that I understand my own career plans, because your career is not going to be what you think it's going to be, right? You're going to make adjustments as you go. And but you do what you can, and you say, okay, will this benefit my career as I understand it? And for like computer science majors, someone will say, well, would it be good to take physics? Yes, it would. That is giving you cross-disciplinary skills. And cross-disciplinary skills are where the high value comes in your career, is that you don't just know your primary area, you can speak the language of somebody else's area and you can work with them, and that means you can get together and you can work with these other people productively to accomplish whatever goal, your employer or whatever you're working on. Right now, these projects I'm working on, it's going to be a lot of mechanical design. They have been a lot of mechanical design as well as the software and networking and that sort of thing. And you need to be able to speak to those people, talk the same language. That was extremely important in graduate school. So look for that. And as I've already said, programming is a skill everybody can really utilize. It's a good thing to do while you're here, while you're when you get to engineering school, you're going to be just buried in work. You may not be able to afford the time to go take some courses that are not contributing directly to your degree. If you can work them in here, it's a good thing to do. And then when you get to a bigger university, you can, you've got these courses under your belt. You can take more advanced programming if you want to, if you have the time. But when I was in graduate school, they had the group that I was working with on languages was working with NASA on a NASA grant, and they got the opportunity to send somebody there to NASA to sit on a team that was validating the design of the current generation of manned spacecraft, the ones that are pretty much getting into operation now. And so they were doing validation. It was 100% software. They were simulating the spacecraft and all of its details to say, is this going to work? And so they needed somebody to sit in on that, and the whole experience was cool because I had an engineer. I have an engineering degree. This is a computer science program, but I have a degree. I actually understand what these guys are doing. I can talk with them about it. So I ended up being the one that went to NASA and lived there for 6 months, sitting in on this team, being their representative, on this grant, which was a lot of fun too. So that was, I guess, what was your question again?
Just what would be good stuff?
Oh yeah, so it's one of those examples of being cross-disciplinary, right? So I'm sitting there with a bunch of engineers and on a team that's doing engineering work, but I'm actually there as a computer scientist, right? So the more you can spread your skill set, the better. It opens opportunities for you. Biology, I think, is one of those fields that doesn't seem like it's connected to software. But if you look at modern biology, which is so heavily now looking into using DNA, right? They're manipulating DNA, they're studying DNA, they are applying changes to DNA, and DNA is a big program, right? So there's software that, and a few years ago, this was a big deal, was just writing the software that allowed geneticists to do their job. They've got that kind of down now. It's sort of an established product is a software that's needed to accomplish it. But the DNA itself, I think, opens up a lot of opportunities for people that go cross-disciplinary there, because DNA is more complex than any software or any software language that we have, but nevertheless, it is a program. It's the programming that operates biology, biological processes.